Imagine if the very core of our planet was secretly being melted by an invisible force. A force so elusive, we're not even sure it exists. Sounds like the plot of a sci-fi thriller, right? But here's where it gets controversial. Scientists now suggest that theoretical dark matter infernos could be doing just that, turning parts of Earth's core into liquid without us even noticing. And this is the part most people miss. The absence of such an inferno might actually be the key to unlocking one of the universe's greatest mysteries. Dark matter, the invisible substance believed to make up about 27% of the universe, has long puzzled scientists. While its existence is inferred from its gravitational effects on galaxies and light, its true nature remains unknown. A recent study by Dr. Christopher Cappiello and Dr. Cappiello Daylan from Washington University in St. Louis explores a fascinating yet unsettling idea. If certain models of dark matter are correct, its particles could accumulate in Earth's core, collide, and release heat, potentially enough to melt parts of it. They call this a dark inferno, a term that evokes images of a subterranean hellscape. But don't worry, this isn't a Hollywood disaster waiting to happen. Instead, the lack of evidence for such an inferno could help narrow down what dark matter actually is. Here's how it works. Dark matter, if it interacts with itself, could annihilate in Earth's core, producing energy that would eventually turn into heat. The rate of this annihilation depends on the density of dark matter, which is why the core, where gravity is strongest, is a prime candidate. But there's a catch. If this process were happening, it would likely leave a signature, such as a partially melted core. Thanks to seismic data, we know Earth's core is mostly solid, with a radius of about 2,500 kilometers. However, Cappiello and Daylan point out that a small, undetectable melted region, say with a radius of 400 kilometers, could still exist. This limits the amount of energy dark matter could be releasing to about 20 terawatts, far less than the heat from radioactive decay in the core. But here's the controversial part. This theory relies on dark matter having specific properties, such as the ability to lose energy when colliding with ordinary matter. If dark matter particles are too heavy or don't interact in the right way, they might not concentrate in the core at all. Plus, if dark matter and dark antimatter aren't present in equal amounts, as is the case with ordinary matter, annihilation rates would be too low to produce significant heat. And if the energy released is mostly in the form of neutrinos, it would be nearly impossible to detect. So, what does this mean for our understanding of dark matter? For lighter particles, this study doesn't break new ground, as existing research already sets stricter limits. But for heavier particles, Cappiello and Daylan's work offers fresh insights into what could be happening right under our feet, or rather, deep within our planet. Their findings, published in Physical Review D, are a reminder of how much we still have to learn about this cosmic enigma. And this is the part most people miss. The very absence of a dark inferno could be telling us more about dark matter than its presence ever could. But here's a thought-provoking question for you. What if dark matter behaves in ways we haven't even considered yet? Could this study be overlooking a crucial aspect of its nature? Let us know your thoughts in the comments. This is one debate that's far from over.